In the previous video, we wrote this function sim that was supposed to simulate like what's the expected return on investment if the true probability of you winning is true prob, if the odds you're getting is odds, and then this reps. The bigger that number is, the more simulations we used, so the more accurate you would expect the return on investment estimate to be. So in this video, what I want to do is practice using Pandas, which is like a method for working with spreadsheet type data in Python. So let me show you an example. So I could do something like pd.dataframe, and then I can say A123. Secretly, what's going inside the parentheses here is a dictionary, but there are lots of alternatives also. And how about C can be 11. So what this does, the keys of this dictionary are saying is those are like the column names, and then it's saying in the first column put 1, 2, 3, in the B column put 4, 5, 6, and in the C column just put all 11s. So that's like the basic display of a Pandas data frame. Let me say that the number of rows of my data frame, which are eventually going to be points on a plot, let's call that with the variable name points. And let's say they're, how about 10 to start? And let me make a blank data frame. So how you can make a blank data frame is you can say index, which is going to be like the names of the rows. So let me say range points. And let me say columns, and here I can give it a list. And the entries are going to be true prob. Okay, it's going to be very similar to our sim function, but a tiny bit different. Then odds. So far it's exactly like our sim function, but then instead of having reps here, instead I'm going to have like the output of the sim function, and let's just have a constant reps up here. Like let's also call reps 10. So each of my simulations for now is going to use 10 repetitions. So let's see how this looks. So it gave me 10 different rows and these 3 different columns with the names that I chose. And if I want to do anything with this, I really need to have a variable name for it. So let me call it df for data frame. So if I just evaluate like that, nothing gets printed. And then if I want to display it, I can just put df on the last line by itself like this. Okay, good. And so these are going to be a bunch of, it's going to be 10 different random simulations. So let's make the first column to be totally random. So true prob, and I'll make these random numbers the same way as before with this random number generator. And I want 1 for each of these rows, so I want points number of them. So now it's filled in that first column with these different uniformly distributed random numbers from 0 to 1. And what do I want the odds to be? Well, for now, let's just keep our lives simple, and let's do df odds always equals minus 110. And here is the hardest part for this data frame. I mean, I can't just give it an independent function to put here in the ROI because it needs to depend on this true probability column and the odds column. So how can I do this? Well, let me show you the syntax. So I'm going to keep the df on a line by itself. And I'm going to apply a function to each of these rows. And if I want it to be applied to each of the rows as opposed to each of the columns, then I need to say axis equals 1. Okay, that's what tells it apply to a row instead of to a column. And then the inputs to this function are going to be the rows. So I'm going to call it lambda row. And so this lambda, that's telling Python I'm about to write a function. Okay, so when I'm doing it in its own cell or on its own line, then you can tell Python you're about to write a function by using this def. But if you want to write it like in a more compact way, just all on a single line, then you can use this lambda. I don't know if operator is the right word. Maybe it's the right word. You can use this lambda. And then what's my function going to be? So here before the colon, that says what my inputs are going to be. So in this case, it's just the row going in. And then what's the output going to be? Well, it's going to be the true prob value from the row. It's going to be the odds value from the row. And then it's supposed to be number of repetitions. So I'll just put in this reps that I defined up here. And so right now, I think I have this defined right, but I'm not telling it to do anything. So I'm going to say, like, let's just look at that. So that returns what's called a Pandas series, but I really want that to go into the ROI column. And each time I evaluate this, I expect to get different numbers in the first and third columns. So if you memorized what numbers showed up before when I printed it out as a series, there's no reason to expect they would be the same here. So let's look at some of these. So here we have a great return on investment. On average, we're making like 90% profit for whatever we're investing. And so why is that? Well, we were getting minus 110 odds on something that's about a 98% chance of happening. So it makes sense that we got a really good return on investment there. And let's increase the number of repetitions to how about 1,000? And let's try to find a very bad one. So here's an example of a very bad one. We're losing about 95% or 94% of our investment on average each repetition. So for each of these 1,000 repetitions. And so why is that? Well, the true probability was about 3%, and we were betting at minus 110 odds. And if we want to look at some statistics for this, I can use the describe method. And a trick I've seen that makes it, to me, easier to look at is to take the transpose of this at the end, so like swap the rows and the columns. And so what information does this tell us? So for example, for the odds column, it was always minus 110. On average, for this particular instance, we were losing 25%. That seems a little high to me. Let's try running it again. I doubt it's going to be losing so much on average. I would expect it to more be like losing 2% on average. Yeah, so here it's down to losing less than 1% on average. And if we wanted to make that number more accurate, we could increase the number of points that we're using. And for the true probability, the more points we use, the closer you should expect this mean to be to 50-50. And the minimum was losing 98% on average, and the maximum was gaining 88%. And let's make it bigger. So let me stop displaying the data frame df. And let's do 100,000 of these. Okay, so right now it's evaluating, but it shouldn't take too long. And so you can see that the true probability got closer to 50%. And what I'm really interested in is the min and the max of the return on investment. So on average, it's losing about 4.4%. The minimum is -1. So in this case, it was like the minimum was lose all your money. What about the maximum? Is the maximum +1? And no, it's not. And why is that? Well, here we're always betting at -110 odds. So best case scenario is you win every time. and then you're betting $110 and you're getting back $100. So you can never get higher than 10/11ths of your investment. So this here we get this 0.909090. And let me show you another way to find that. What if I look at 10 divided by 11? Okay, we get this same 0.909090. That's like when you're betting at minus 110 odds, that's the best case scenario. If you win every single bet, then you get 10/11ths of your investment back. Okay, I mean, plus you did not lose your investment, so it's still a great outcome, but it's not that you double your the amount you started with. It's a little bit less than that. Okay, so what do I want to do next? So let's take the same df and can't display all 100,000 rows, but here is some subset of them. And I mean, our overall question is about the break-even percentage, about what true probability corresponds to a return on investment of 0, like you're neither making money nor losing money. And so let's look at the sub data frame. So for example, I can do df.loc that's saying like, give me this location. And then I can say, I want the return on investment column to be less than 0.01. So now we went down from 100,000 rows to 52 or 53,000 rows. And so what if I want the return on investment to be between plus 1% and minus 1%? So I can say bigger than minus 0.01. And if you're used to Python, you might expect to write an and here, but in NumPy and in Pandas, if you want to say like and of things, and it's not just a basic true or false from within Python, then you have to use this ampersand symbol. And for or, in regular Python, you use or, but if you're doing it like element-wise for some Pandas series like this, then you would use this or. So what would happen if I did this? Can you predict? Then I'm back to all 100,000 because every entry in the return on investment column, it's always either less than 0.01 or bigger than negative 0.01. Okay, but with the and is what I'm really interested in. Okay, so now we're down to 1,091 rows, so a little over 1% of the rows were saved. And what if instead of, so this, you should think of this as like saying, give me those particular rows. So let me show you what this looks like by itself. So here it's a bunch of falses, but about 1% of this was true. Okay, and then we were plugging it in here. So it was like saying false, don't keep the 0th row, false, don't keep the 1st row, and so on. And so what's in here currently inside this .loc with square brackets, that's saying which rows to keep. I can also say which columns to keep. So like, let's say keep the return on investment column. So notice these are all going to be between negative 0.01 and positive 0.01. But that's not really the interesting part. The more interesting part is this true probability. And so what type of thing is this? Oops. This is a Pandas series. And I can take the mean of this. So here I'm pretty close to my 52.4 from the beginning. We're going to get even closer, but This method, this got me 52.3%. So last thing I want to do is I want to get some more interesting odds here. So let me just copy this. And let me make these numbers a little smaller to start. And let's look at this data frame just to make sure I haven't broken anything. Yeah, so that looks good. And so last thing I want to do before ending this video is I want to get a more interesting variety of odds inside this odds column. And so let me make a new cell up here and work on getting some of our choices for the odds. So there are a lot of different ways I could do this. Here is one way. I'm going to take a range starting at minus 110, going down to minus 1000, and going down by negative 10 at a time. So you can think about this as a selection of minus odds. And one thing to be used to in Python is that almost always the second bound does not get counted. And so if I want negative 1000 to show up, then I should really go past it. Hey, I could even just go one past it. That would be fine. And so it's like saying, don't include the endpoint and don't go past it. So for 1000, it took away the minus 1000, but as soon as I go a little bit past it, then it will include the minus 1000. And so let me copy this and put it here. And what would be a good thing to call this? How about I call it odds array? And so I don't actually know what will happen if I put it in here. Let's see what happens. Okay, so it doesn't let me do it, and the reason is because this thing had length 90, whereas my data frame had length 10. So, and I could say give me a length 90 data frame, and then it works. Okay, and then you can see that this is exactly my odds array here in the odds column, but that's not a very robust way, and I also want it to be more random than this. So what's another way to do this? So another way to do it is to say, from this random number generator, give me a choice. And then within choice, okay, let me see if it will show the documentation. No, I guess it's not showing me the documentation, but the things that should go here are the collection to choose the random choices from. So in this case, odds array. And then it should also be how many choices do you want? Okay, in this case, it will be points. Okay, so that guarantees that it's the right number of the right length for the number of rows. And you can see that now it's a much more random collection in this odds column. And so that's pretty good. Only thing I don't like is that they're only the minus numbers. There are no plus numbers. So I'm trying to think about what the way to do this is. Let me call this x1 equals this. And let me say x2 equals the range starting at 100, going a little past 1000, and going up by 10. And then if I want to join these things together, so let me show you what x2 looks like. Then I can use numpy.concatenate. And I always make this mistake. I always write something like x1, x2, but you have to have it in one more set of parentheses. And sometimes that's useful. Almost always it's not useful for me. But this just puts my two numpy arrays one right after the other. And maybe you don't like the fact that they're going down this direction and then they start going up. I'm just going to choose random numbers from those eventually, so it doesn't really matter. So let's see. Let's put this in here. And now I need to save this as my odds array. And so after I evaluate this, I hope to also see some plus numbers in here. Yep, so there are some plus numbers and some minus numbers. And we can also make it bigger. And it's good to try changing those parameters every once in a while, just to make sure you haven't secretly used some repetition that's going to break something. And let's look at the df.describe again. Okay, this is what gives me those summary statistics. And let's look at, again, the return on investment row, this bottom one. And so notice that now the maximum is this 8.215. And so that's much bigger than before. Remember, before the biggest we ever got was 10 over 11, so like 0.9. And why is that? Well, because now I have plus numbers in here, then I can get much more than my total wager back. So for example, if I'm getting plus 300 for my odds, then maximum possible return on investment would be 3. Okay, get 3 times your wager back. And so let's just take a look at what are the rows where we get close to this maximum for the return on investment. So I can, and then maybe I'll show you another way to do this. I can say, show me where the return on investment is bigger than 8. Okay, and so there was just one. Let's make it a little bigger. So here are all the cases where the return on investment was bigger than 7. And so out of the original 100 rows, there were 4 where the return on investment was bigger than 7. So for example, here I was getting plus 920 odds on an 84% bet. Yeah, I think that's where I'll stop this video. And then when we come back, I will show you how to plot the information from that data frame using the visualization library Altair.